Hi everyone, welcome to our first workshop in the Surreal World Assets buildathon. Today we have Building on Story Protocol 101, so I hope you're ready for that. We have Romain joining us from Story, who is getting ready to come up on stage with me now. As always, everyone, this workshop is being recorded and will be available for you to review tomorrow. But please take the opportunity being here live to ask questions and get any clarification on things you might be confused about. Romain should be joining me any second now, and then we'll get right into it. The expected time for this workshop is an hour, so I hope you're ready to sit down, relax, and learn. Romain, thank you for joining me. We're both in our blue void. It's great to see you again. I will hand straight over to you, and we can get into the workshop.
Hi, Rebecca. Thanks for organizing. Hi, everyone. My name is Romain. I'm working at the protocol team at Story. Super excited to welcome all of you guys today for one of the first, if not the first, right, workshop of this hackathon. So super excited to present all those materials to you guys to help you build on the protocol. So let me share my screen. Okay. All right. So we will begin in a couple of minutes just to let people connect. But basically, the intent of this workshop is to help you understand the structure of the story protocol stack, how it works, and how you guys can build on top of it and interact with it, especially through smart contracts. So it's already 8 a.m. Yep, let's get started. All right. So building on story protocol 101. So we have a pretty packed agenda. First, we will go into an overview of the protocol. Then we will deep dive into the proof of creativity protocol, which is our smart contract protocol that lets you program IP. And we will go into details of how it works. Then we'll go over a coding demo, of course. And I'll leave time at the end of the workshop for Q&A. So let's get started. Basically, the overview of the POC protocol and the story stack is the following. So story is basically the whole infrastructure that lets you program IP, and it has four main components. So first, the proof of creativity protocol, which is the main thing we're going to explore today, is the smart contract protocol that lets you register and program IP. It's powered by our programmable IP license, which is an off-chain legal contract that is mirrored into on-chain smart contracts with encoded legal terms. So this is how you define the license of your IPs. All of this is running on the story layer 1, which is a layer 1 pretty much optimized to handle IP data structures, which can translate into a lot of graphs, because, for example, you can have an IP, then a child IP, which is derivative of the first one, then a grandchild IP, and so on and so forth. So this is why we built a purpose-built element for that. And then on top of this, we have the story application ecosystem with projects like Arya, Poseidon, hopefully other projects that you guys are going to build during this buildathon. To focus a bit on the POC protocol, it's made of, again, four main components. So first, the IP asset is the asset itself, like it's the intellectual property itself. It's represented as an NFT, and it has an IP account associated to it, as we will see in further details in the next sections. Then you have the modules. So the modules basically are what allow to perform actions on this IP. So you have the royalty module, which handles anything payment related. You have the licensing modules, which handles everything related to minting a license. Minting a license allows you to use an IP within certain license terms defined by the license that you mint. You have a grouping module, allowing to group IPs together and manage them in a logical way. For example, manage several IPs under a brand, for example. And finally, a dispute module, which is a built-in smart contract-based arbitration system, which resolves everything related to IP infringement, improper registration, plagiarism, and so on and so forth. Then we have the registries. So the registries are basically the storage layer of the protocol. So for example, the IP asset registry handles all the IP asset registration, license registry, same for all types of licenses, module registry, and so on and so forth. And finally, the access controller. We won't focus too much on this in the workshop, but basically the access controller is what allows to properly allow access to the IP, basically meaning defining who can perform what action on your IP. So the IP owner can pretty much do anything, and then you can define authorized operators that can trigger a particular module function, for example, on behalf of the IP owner. So that's it for the protocol overview. Let's go over now the programmable IP license, which is the legal off-chain document that is then mapped into on-chain terms. It allows IP owners to attach customizable terms to their assets. So it defines terms like whether your IP asset can be commercially used or not, whether it has like derivative rights, meaning can somebody register a derivative of your IP, whether someone using your IP should attribute you for that, meaning like give you credit, and so on and so forth. So, and we have a couple defined already programmable IP license flavors. For example, commercial use, which allows someone to make money out of your IP, but not register a derivative, for example. Non-commercial social remixing, which allows anyone to create derivatives of your IP, but not to make money out of it. So we have a couple already defined set of license terms you can pick from, and you can also define your own customized license terms. I didn't state it specifically, but basically an IP can be, the definition of an IP is super broad. So it can be, of course, creative work, like a music, a movie, whatever, but it can also be like data sets, for example. So the definition is really actually pretty broad. Now, let's deep dive into the proof of creativity protocol, which is the smart contract-based protocol that powers the story ecosystem. I know this is a lot of information to digest in a couple minutes, but we will go into a demo afterwards, so hope there's not too much. All right, so an IP asset. Basically, an IP asset represents pretty much your intellectual property registered on-chain. It's registered in the form of an NFT, like a standard ERC 721 NFT. And then each IP asset has what's called an IP account, which is a token-bound account, meaning that it's a smart contract account that is tied to the NFT. And this account can own assets, can interact with other smart contracts. So basically, this is what allows your IP to become actually programmable. So the IP account stores everything related to modules and IP metadata. And whoever owns the IP asset controls the IP account and owns the underlying intellectual property. The IP metadata is basically a standard that recapitulates all the information about your IP, similar to NFT metadata, but a bit different because it's actually specific to IP. I'm going to pause here for a second and look at the chat to see if everything is good on our side. GM everyone. All right, looks like we're good. let's move on to licensing. That's not a simple module, so let's unpack all of that. So the licensing module is the module that manage everything license related. License related meaning registering license terms, meaning different set of terms you can then attach to an IP. It manages minting license tokens, meaning a license tokens is what allows you to exploit an IP under a specific license. Like it's like say, hey, I want to exploit this IP under this license. And what allows me to do that is that I minted a license token under those terms. It handles registering IP derivatives and also setting license configs. So that's a lot of new notions here. So license token are NFTs that allow to use an IP or register an IP as a derivative of another based on the license terms defined in the token. And like the license terms are basically a particular combination from the values of a license template, as we discussed earlier. And a license template could be any legal framework that defines license terms for an IP. And the programmable IP license we talked about just earlier is the first example of a license template, but there could be in the future other variations of those license templates. A licensing config is an optional configuration that you can set to override certain fields and set a bit of custom configuration on a particular IP with particular license term. Like say, for example, your IP has license terms for which the minting fee, meaning the fee that someone has to pay to mint the license token from this IP with this license is to 1, but you want to keep those license terms, but overwrite the minting fee to set it to 3, for example, because you believe one should pay more to use your IP, then you can use the license config to set this particular parameter. And finally, the licensing hooks also allows you to define further custom logic that will be executed like similar to a Uniswap hook for so those of you guys who are similar with Uniswap hooks are executed before doing a swap. The licensing hooks are custom defined and executed before minting license tokens or registering derivatives. So for example, you could set a limit on the number of license you can mint from a particular IP and a particular license. You can also lock a license, meaning no one can ever mint again a license token from this license. You can set whitelist, meaning that only some addresses will be authorized to mint licenses of your IP under this license, and so on and so forth. Those rules are pretty customizable. You are very welcome, guys, during this buildathon to create your own hooks and even propose them. It will be super interesting. So yeah, that's a lot of customization on this side. Now, let's move on to royalty. Royalty module is also one of maybe the most complex ones. So we will also unpack it step by step. So basically, as we said earlier, the royalty module handles anything payment related. So for example, let's say I use the IP of a friend, but then this IP is not free. I have to pay them like royalties for the use I made. If I register a derivative and I earn revenue from this derivative, then I will also have likely to pay a percentage of this revenue to the IP I made the derivative from. Like let's say, for example, I like a music and I want to use a sample of this music to create my own, and then I make money out of my new music, then I will have to pay a percentage of what I made to the original music. And this is all automatically handled through smart contracts by this royalty module. So to understand the royalty module, we have to define what's called first a royalty stack. So basically, the royalty stack is what each IP owns to its ancestor. For example, in this picture, we have an IP asset 1, which is the original IP that asks for 5% of the revenue from any child IPs. Then you have the IP asset 2, which is a derivative of the IP asset 1 that asks for 10% of the revenue that is made from any children. And then you have the IP asset 3, which is a derivative from the IP asset 2. But the IP asset 2 is already a derivative from IP asset 1. So what's happening here is that the IP asset 3 not only owns 10% of its revenue to IP asset 2, but also 5% of its revenue to IP asset 1. So that's what we call the royalty stack. And the definition of this stack depends on the royalty policy that you choose in your license terms. You can choose between two royalty policies, absolute or relative percentage. Simply put, if you choose this example that we just made is how the absolute percentage policy works, but if you chose the relative percentage policy, the IP asset 1 only would ask 5% from its direct child IPs, so only asset 2 would have to pay 5% to IP asset 1, and then the IP asset 2 would ask 10% from its direct children, so IP asset 3, and then the IP asset 3 would only have to pay 10% to IP asset 2 and wouldn't owe anything to IP asset 1. So that's basically how the stack and policy works, and that's the core of the royalty model. Now we need to look at how the payment is handled and who receives this payment. So each IP has a royalty vault, and this vault is a separate smart contract. It's an ERC20 contract that receives the revenue generated by the IP asset. The ERC20 contract of the vault always has 100 royalty tokens, and those royalty tokens represent a share of the revenue generated by the IP that you can pretend to. So originally, 100% of the royalty tokens are owned by the IP asset itself, specifically the IP account. And what it means is that originally, the IP asset associated can claim 100% of the revenue it generates. But then, for example, if you are the owner of the intellectual property asset, you could distribute those royalty tokens to any other address you'd like. It could also be a defined product, actually, so that those addresses can claim a share of the revenue generated by the IP. So let's go over a quick example and see what is the flow of a payment using the royalty module. So let's say you have this nice little guy that pays because he's cool, so he pays a tip of 100 wrap IP, which is the ERC20 token used to pay royalties to IP asset 3. So for that, it will send this wrap IP to the royalty module first. So that's the payment initiation. Then the royalty module will split this payment between the IP asset 3 and the other two ones, because as we saw in the stack, the IP asset 3 needs to give away 15% of its revenue because it's a derivative of two other assets, right? So the royalty module will give the 85 wrap IP due to the IP itself to its vault, and then will send the 15 other wrap IP to the policy contract. And this policy contract will split accordingly, according to the royalty stack, between the two other vaults of the two parent IPs. And then, because originally the IP itself owns the royalty tokens, the IP itself can claim all the tokens that are sent into the vault. So that's basically how the payment works using the royalty module. Then the dispute module is another of our core modules that allows you to handle everything related to dispute, related to improper registration, infringement, directly on chain. So it's a way for users to raise and resolve disputes through an on-chain, fully on-chain arbitration system. So the main components of this system are first the arbitration policy, which defines who handles the arbitration and how. So the currently supported arbitration policy is the UMA arbitration policy. So we have a lot of docs about that if you guys want to dig deeper into it, into how it works. Then the other component is the arbitration penalty. So the penalty will define what happens basically once an IP asset is tagged. Tag meaning it has been disputed and the dispute has been seen as legit by the arbiter. So basically what happens is that when an IP asset is tagged, it cannot mint licenses anymore. It cannot be a derivative of any parents anymore. It cannot claim royalties, and all existing licenses of those IP assets become unusable, basically. And what defines the reasons for being tagged is the dispute tags. So, for example, improper registration, content standard violation, and so on and so forth. To quickly walk you guys over the flow, a user can raise a dispute concerning an IP asset. It can drop it if it believes it has been resolved. Then the arbiter, so in our case, UMA, evaluates the dispute. Then it sets its judgment. Is the dispute legit or completely not? So in that case, it's legit. Anyone can tag the derivatives of an IP that has been disputed, because like obviously if an IP is not legit, the children of this IP, meaning assets originating from this IP, are not legit either. So this is why we can tag the derivatives directly. And then if the user thinks the dispute has been resolved, it can resolve it, and then the IP asset and its children become usable again, and you can also resolve the dispute on the children. All right, so last but not least of our modules, the grouping. So the grouping modules enable the creation and management of group IP assets. So basically it's when you want to, for example, let's say you're an artist and you want to manage like all of your creations all together, then you could create a group IP to manage all those assets. So group IP assets are pretty similar actually to standard IP assets. They're created using an NFT, they have an IP account, and also there is a royalty pool for the group, and then the payments that will be made to this group are splitted between the IPs that are basically part of the group. So the owner of the group can add or remove IP assets. However, once derivatives of a group are registered, the group is locked, meaning no IP can be removed. And there are a couple restrictions specific to groups, like they can't use LAP policies, can't be derivatives of another IP, and the lock, and have maximum 1,000 members. So there are a couple restrictions specific to the group. All right, so far so good. Then to interact with all of these modules and register IP assets, which can be a bit complicated if you do it transaction by transaction, we also created a whole set of smart contracts, what we call the Story Protocol Gateway, which is a set of peripheral contracts that allows you to basically simplify the interactions with the protocol by combining independent operation that you would always perform at the same time. For example, let's say you want to register an IP asset and attach specific license terms at the same time. Thanks to the gateway, you can do it by calling a single function in a single transaction. We also have a SPG NFT, which is a ready-made NFT collection that you can use to register an IP asset from in the case where your IP asset is not already an NFT registered on-chain. So to not have you creating your own collection of NFT and minting out of it and so on and so forth, we can directly mint and register an IP asset at the same time, thanks to this SPG NFT collection. Then we also can batch several SPG workflow calls together. Let's say, for example, if you want to mint and register 1,000 IP assets at the same time, it will be a bit complicated and a bit not as efficient to do it in the same transaction. So we have built-in multi-call function in smart contracts that allow you to batch several calls. And in case you have a custom flow for which the multi-call function is not directly available in our contracts, you can always use the multi-call tree smart contract deployed on the Story blockchain that allows you to create your custom multi-call and batch call together to register a lot of IPs or do another set of actions by batch at the same time. We also provide the SDKs, and if you are very interested in interactive with Story through the SDK, I strongly advise you guys to attend the workshop that will be held by Jacob in the coming days that will walk you specifically through the SDK. So the Story SDK provides you a high-level client library in Python and TypeScript to interact with the POC protocol, and for that it uses the peripheral contracts. All right, so far so good. It's time to leave the slides away and to go over the demo. So I'm gonna have you guys clone the repository that will be sent in the chat. All right. Please let me know once it's good for you guys. And I'm gonna switch to the code. Gonna wait a minute just to let the time for everyone to clone the repo. Nice. Once you guys have cloned the repo, you can install the dependencies by typing the yarn command in your terminal. I'm gonna send it in the chat. And I'm gonna do it just for the purpose of the demo on my own terminal. On my side, the dependencies are already installed. So I'm gonna let you guys a couple minutes just to finish cloning the repo and type in a command. Piplabs is the core team building Story protocol. All right. Please let me know, guys, if you're having any issues or need a bit more time, but otherwise, we are gonna get started very soon. All right. Looks like we are good. We're gonna get started. So this repository uh, basically presents a couple of ways you can interact with the story protocol, both core and periphery contracts, and highlights the core flows, let's say, that you can do with the story contracts. We're gonna go over the basics. So first, starting with this IP asset register file, we will basically what we'll do is that we will run a couple tests, that will exemplify how to interact with story protocol, and those tests are going to be run against our testnet URL. So it will be exactly as if we were interacting with our actual testnet, except that because it's local test, we won't have to like set a private key, pay gas fees or whatever. So the first file we will go through is the registration flows that will show you how to register an IP asset on Story Protocol. We do a couple setup for that. For that, we create a new SPG NFT, which is the same SPG NFT we talked about earlier. And then we will do two ways of registration. First, we will directly register an IP asset by interactive with the IP asset registry directly using the register function, as you can see there. So it takes simply the chain ID of the block, the NFT address collection you want to mint from, and the ID of the NFT you want to register an IP asset from. And then we will also do the same using this time the periphery contracts. So we will for that interact with the registration workflow smart contract. And this workflow allows you, for example, as you can see here, to both mint and register an IP at the same time. So then the function is a bit more complex because we have to both mint and register our NFT and IP asset at the same time. So once again, you take the address of the NFT collection, you take the recipient of the IP. Then, as we saw earlier, the IP metadata is very similar to NFT metadata, but a bit specified to IP. So it takes a metadata URI for IP, which is where on the internet is the metadata about your IP, like for example the files or whatever registered. So as you can see here, it's on IPFS. We have a couple documentations on how to register data on IPFS. So if you need for your during the buildathon to do that, guys, we have extensive documentation on how to do it. Then the hash of the metadata. So for example, there the metadata is super simple. It's just title, description, and a creators array and a created at. Then you have, as you could have on a basic NFT, the NFT metadata URI and hash, very similar to IP metadata. So I'm not gonna go into a lot of details into it. And what we're gonna do here is basically interact with our periphery contracts to both mint the NFT and register an IP in the same transaction. So if you want to test this, you can guys run this simple command that will run both tests. So I'm gonna copy it and paste it into my terminal. All right, so far so good. So those are the ways you can simply register an IP, and the way it's gonna work for the other files and other workflows in this demo is that then here I showed you how to register an IP. Then, for example, in the next file of this demo, I'm going to assume we already registered an IP, and we will do what's next, basically. What can you do once you register an IP? What you can do is register license terms, because let's say you want to define your own set of license terms. For example, define whether license terms that are minted from your IP are transferable, what royalty policy you want to use, what's the minting fee someone has to pay when they want to mint a license from your IP with those terms, whether someone can commercially use your IP to make revenue out of it, and so on and so forth. So you define all of this through this build term structure, and then you simply call the register license terms function of the programmable IP license template smart contract. So once again, let's go through a quick testing. You can do it, guys, with me as well. All good. Yeah, so the purpose of this repository is really to provide you with the example of the core flows you will need to manage if you want to program IP, and show you how to do it easily, and it's sort of a boilerplate you can then derive other workflows or complex applications from. So that's really a source you can pick from when you don't know how to do something. There are many chances you can see how to do it there. Then once you have an IP and once you have license terms, what you want to do? Maybe you want to attach those license terms to your IP, so that then anyone can mint license terms to use your IP under those terms. So how you do it? Then in the setup, basically we do what we did before, which is registering an IP and registering license terms. And then if we want to attach those license terms to an IP, we will do the following. We will interact with the licensing module, which is a core smart contract, even though we could do it using some periphery workflows to, for example, register an IP and attach license terms in the same transaction. So then we attach the license terms on our IP ID using our programmable IP license template, using the particular terms ID which are associated with the specific set of terms we defined earlier for our license. So let's do this. So far, so good. And as you can see here, if we try to get the attached license terms from this IP, the first license terms attached, so at index 0, then it corresponds to the ID of the license terms we just registered. So that's to attach license terms to an IP. And then once you have an IP that is registered with license terms attached to it, what you can do is mint a license token from this IP, so that then you can use this IP. For example, if you are not the owner of the IP and you want to use it under those license terms, you can mint a license token for that. So once again, in the setup, we do what we did before. And then how it works to mint a license token is that you interact with the licensing module and you mint license token of a particular IP using the same license template as always, using the particular license terms ID you want to mint a license from. Let's say, for example, you want to mint 2 licenses. The receiver is Bob, like Bob want those licenses. You can ignore the royalty context parameter for now, you just leave it empty. Then you define the max minting fee and revenue share. 0 means unlimited in this case. So you mint those license token, and then Bob will have, as we see there, Bob will own 2 license tokens of this IP. Once again, the process doesn't change. So far, so good. Then what you want to do after that is maybe you want to register a derivative of the IP you just minted. So in this case, the setup, as always, just like what we did before. So then let's say you want to register a derivative of an IP. You don't own it, but you want to use it under certain license terms. So then what you want to do is register your IP. First, you mint and register your own IP. And then you say, hey, my IP is a derivative of another IP. So you have 2 ways to do it. Either you mint license token before registering the IP, and then basically we burn this license token when registering your IP as a derivative. Like you have to consume your license token to register the derivative. You don't need to burn it manually, of course. That's done directly in the in the Story Protocol smart contracts. Or you can also register a derivative without having minted the license token first by specifying which license terms ID you want to register an IP derivative from and paying the appropriate fee. So here, what we're gonna do is that we are gonna register a derivative with the license token that we minted earlier in the setup for our IP by specifying what's the derivative IP, what license tokens we want to register a derivative from, which are basically the terms under which you are gonna be able to use the parent as a derivative. As always, the context is empty, and the max royalty token share is unlimited in this case. So let's go over it. Once again, we can test it under our testnet URL. All right, sounds good. And then the last thing we're gonna do, we are right on time. So the last thing we're gonna do here is that we are gonna pay royalties to those license to those IPs that we registered. So we are gonna go through 2 flows of royalties and see how the royalty can be claimed by an IP when it's paid to it. So in the setup, as always, we do the same thing we already did in the previous test. So first, let's go over the first scenario. So in that test, what we're gonna do is that someone will gently pay some tips or whatever to an IP, to Bob's IP in this case. But hey, as you remember, guys, Bob's IP is now a derivative of Alice's IP, right? So if Bob receives revenue, Alice should be able to claim a part of it, right? So let's see what happens when we pay royalty to Bob. That's what we do here. Then here you will use the royalty workflow, which is a peripheral contract that simplifies royalty interaction. And then we will use it to claim our revenue for an IP. So what we are going to do here is basically say, hey, look at Alice's IP and update all the balances so that Alice's IP gets the revenue it's due. So that's what this function does. So the ancestor is the Alice's IP. It's also the claimer. The child IP IDs is basically Bob's IP. We specify the royalty policy that is associated with the derivative relationship between Bob and Alice. We specify the currency tokens. Here, the currency is how we pay the IP is a mock ERC20, which is whitelisted on our testnet to pay royalties. On mainnet, you will do it with wrapped IP. And what happens is that when when this function runs, Alice's IP has claimed two mock async20 tokens because Bob has been paid 10. Under the license terms, Alice's IP can claim 20% of the revenue of Bob's IP. So then the balance of the IP account is 2. An IP can be identified by its IP ID, which is the address of the IP account, for context. And then, as we see, Bob's IP ID, unfortunately, has lost 2 mock async20s in the context, in the process. So that's when you pay an IP that is a derivative of another. And then now we can look at what happens when you pay a minting fee. Basically, you would pay a minting fee when you mint a license token using a particular license terms from a particular IP, and those license terms specify, hey, if you want to use me, you are gonna need to pay some fee. So that's what we're gonna do here. First, we register new license terms that will specify a minting fee, meaning a fee the user will have to pay to mint a license token from those license terms. So we first register this. We attach them, as we did earlier in the demo, to Alice's IP. And then what we're going to do is that Bob will mint license tokens from Alice's IP. And then what should happen is that when Bob tries to mint those license tokens, Bob has to pay a fee to Alice's IP. And to check that, we will look at what happens when we once again use the royalty workflow peripheral contract to claim all revenue from Alice's IP. Once again, the child IP ID is being Bob's one. And what we're going to see is that the Alice's IP has actually claimed one mock ERC20 token that was due after minting the license tokens. So for the last time, let's run those tests for the demo to make sure it works. All good. So that was it for the demo. Hope the pace was right, guys. That's a lot of info to absorb it in a short amount of time. That's for sure. We have 10 minutes left for Q&A, so feel free, guys, to ask me any questions about how the protocol works or anything protocol related.
Thank you very much, Romain. While you were talking earlier, Samuel had asked if you share a demo repo with Python scripts. If I'm understanding that correctly, Samuel should attend the session with Jacob on Friday to do with the SDK. Is that right?
I think Jacob is focused on the TypeScript repository, but it it should be findable. There should be findable. Yeah. But everything SDK related will be covered in much more detail on Jacob's session. Yeah, that's right.
From kind of a follow-up to that, can you give us an overview of, in your opinion, what the easiest languages to work with Story are? I mean, I know a lot of people are more familiar with Python, and so we'll opt for that. But would you say that the TypeScript SDK is more comprehensive or better to use in this case, or is Python all right?
I'd say the TypeScript SDK is likely a bit easier and comprehensive to interact on, unless you have a use case maybe that is really AI related, in which case you will need to use AI libraries in Python and interact with the story protocol in Python. In which case that's totally doable, and you're also very encouraged to use the Python SDK, which it also works pretty well. But I would say if I had to pick one, the easiest is likely TypeScript.
Nice. I wanted to make you pick one just for people's knowledge. Anonymous attendee has asked how are people aware of such IP existing in the registry, and how do they know they need to pay to license?
Basically, you pay a license when you want to use an IP. So if on the story blockchain you say, hey, I want to use this IP asset, like say for example it's a music, you say I want to use this music, for example, because I hold a disco bar and I want to use this music in my disco bar on Saturday night. So I'm gonna generate revenue out of it indirectly because I'm gonna earn money from my bar for sure. But if you want to use this music, you have to mint a license. And to mint this license, you automatically, through the smart contract of Story, have to pay this fee. So that's how it works. Yeah.
Grace has asked, how are IP violations spotted? So I guess that's to do with how would a violation of using someone's IP when you haven't paid for it, how would that be spotted?
Yeah, that's a very good question. Yeah, we have two ways to spot IP violations. The first one is, as we said earlier, the dispute module. Basically, if you are the owner of an IP and you believe your IP has been misused, for example, let's say someone has registered another IP using the same music as you, but without paying you whatsoever for this, you can raise a dispute as the owner. And then if the dispute is legitimate, the IP of the other person won't be usable anymore. So that's the first way. And the second way is that we have infringement checker services that run all over the network and flag any any IP that looks suspicious. So that's not enforcement. In that case, it's more warning. But we have those services running and scanning all over the network at any time.
Sorry, I was just finding a link to a blog there for which I think might give some more information on that. But Grace did ask, how are the disputes processed? So I guess that's to do with the IP owner makes the dispute, who sees that.
Yeah. Great for the link. Thank you, Rebecca. So to go over quickly on how disputes are processed, theoretically, we can support different arbitration policies. Currently, we support one, the UMA arbitration policy. UMA is an optimistic oracle. Basically, what UMA does is that when you want to raise a dispute, say, hey, this guy has registered the same music as me without paying me, you will submit this claim with a proof, and then the UMA oracle participant, which is a set of decentralized participants, will review this claim. Then, if in a set amount of time no one has contested this your dispute, meaning everyone thinks your dispute is legitimate, then your dispute is validated, and the IP that you tagged will be considered illegitimate. However, if someone see that your claim is false and can submit a proof for that, then your dispute will be dropped, and also the people that voted for your dispute will have their stake in the oracle slashed. So people are pretty much incentivized to tell the truth, because if you vote against the truth, you will lose money, basically. So that's how it works. It works pretty much like an optimistic rollup, if you are familiar with it. But in the future, we could also support other different policies. Yeah.
And I kind of have a follow up there just because I'm interested. How would that work in the case of an IP violation being sort of subject to like opinion? Like if it's not an obvious yes or no violation, because you're incentivized to tell the truth, of course, as a validator. But if you don't know if it's like it could be, it might not be. How does that work?
Then it's the majority that votes for it, basically. The majority of the Oracle participants.
Okay, very interesting. Thank you, Grace, for those questions. Useful, I guess, for everyone to know as well, and hopefully helpful for yourself. We still have a couple of minutes left for any more questions before we finish out the session. So now is your last chance. But otherwise, in the meantime, Romain, thank you for coming in and delivering this session. The recording will be available tomorrow for anyone who wants to follow through along with the repo again. We'll also post the boilerplate on the platform page. So if you want to access that again, if you didn't clone it earlier, then you can. Especially those of you, I know some people came in late, you can catch up again tomorrow. It looks like we don't have any more questions. So if everyone is okay, we'll end out the session for today. So enjoy the rest of your morning, evening, afternoon, wherever you are. And we'll see you all again very soon.
Yeah, thank you very much, guys, for attending. Hope it was insightful, interesting, and I can't wait to see other projects that are going to be built. Thank you, guys. Thank you, Rebecca.